grab that bucket of popcorn and settle into your seat for a show from Beda Hammerschmidt, who is the Oracle developer who builds the JSON functionality into Oracle Database, as he explores Dataguide, a fantastic feature that allows you to discover information about the structure and content of JSON documents that you've stored in Oracle Database. Beda, take it away.
So I've prepared a table where I pulled JSON data from Twitter. So the table is quite simple. Every row has an ID and a column JCall, which contains Twitter data as a JSON document stored inside a club. And if we count them, we have exactly 100,000. So the describe doesn't really help us understand the data at all. All we know is that this is JSON. There is an isJSON check constraint on the JCall. So let's just look at one row. I randomly picked ID 1, 2, 3, 4, 5, and let's take a look at the data. So this is one real Twitter tweet. So we see that it has field names called created at, which has a date. It has the text. I guess this is the actual tweet that people typed in on their phone. And it has basically, if someone replies a tweet to another, you would, I guess, get an ID here. So we can scan this document here and get somewhat of an understanding of it. And we see that there's actually a lot more fields than just the text and the date. There is like counts if something has been retweeted, possibly sensitive, interesting. Seems they're doing some analytics on this to see if people post some inappropriate stuff. Well, but scanning all these 100,000 documents would be hard. How do we know what the actual schema is, what the field names are that occur in the data, and what the structure is? So Twitter is just taken here as an example. Imagine you receive JSON data from a source, third party, or another feed, and you just want to see what data is in there. How can I query it? What are the data types? Then sampling the documents, obviously not a very good idea. So we've developed the JSON Dataguide for this. Let's just issue a query here, which calculates the JSON Dataguide. So it's a select statement, select JSON Dataguide from JCall from our Twitter table. And what this does, it is scanning the entire 100,000 documents, sees what field names do occur and what data types they correspond to. So let's just run this query and see the output. So it is now scanning the 100,000 documents on my small machine here. So this is why it takes a while, but it actually did this in a few seconds. So this is not a pretty printed format. So it's basically all without any white spaces or indentations. So let's just rerun the same query here. And I show you there's an option called JSON pretty. So now we get it pretty printed. So again, I run this, it will scan the 100,000 documents and hopefully it returns us the same information in a more readable format. And it does. So this is a long list of objects inside an array. Let's go maybe to the top. Will be many pages here. Okay. Here we are. So the returned data itself is JSON. It's an array. We see this with this square bracket. And then we see inside array basically just objects. And each object tells us what is the path leading to the field. So there's $ID, $geo, and geotype, geocoordinates. It also tells us what the number is. So we know that ID is a number and its length is up to 32 characters. Similarly, we have encountered one field which is $geo and its type was null. And we also encountered geo as an object where the contents was up to 64 characters long. So the length is always a power of 2, so it could be 63 or 62 or something bigger than 32. Then it jumps to 64. So we see that there is some schema flexibility here, or the path $.geo sometimes seems to point to null and sometimes there is an object. If it is an object, we will see that one of the contents is a type, which is a string up to 8. And we do have coordinates. This is an array. And inside the coordinates, this is an array of numbers. So it's probably latitude, longitude things. We do have a language field, or just $.lang. Its type is a string, and the length is 2. So this is most likely some abbreviation for a language, like EN for English or ES for Spanish. $.text, this is what we've seen before. This is the actual tweet, and the longest we've found was fit into 512 characters. And there is users. So this is like, this goes on for pages. But this is now an accurate summary of all the field names that do occur in this JSON data. And it also tells us the structure. So we know there's a field called entities, which has a sub-object media, which has sub-object sizes, and an object which is small. So this way we can understand more of the JSON data, and we can use this information to also query the data. So I'm just trying to go back. Yeah, it's quite long. Would be interesting to see how many there are. So let's find this out. So the next thing is a query on this data guide. So I use a with clause here, with data guide as select JSON data guide. So this is basically the query we just ran, and we give it the alias data guide, and then we query the data guide using JSON table. So we iterate over this long array, so this array here, which ends with the square bracket here. And for each of these objects, we project out the path and the type. So this will basically allow us to see this JSON data guide in a flat relational view. So actually here we see we have 384 fields, and those are the paths and the data types. So now I could do more stuff with it because I have now the path and the data type in a relational format. So with our simplified syntax, so just let's scroll on. I think there is a field, if we scroll through here, which is called language. There's actually more than one. There's language here quoted. I was looking for the one under user exactly. So there's a path called $.user.lang. This, I guess, will give us language information about the user, or what the tweet, in what language the tweet has been written. So now I can do a select distinct to filter out all the languages we have here. I have to put user in double quotes as in a path expression here, just because it's a reserved word. I don't have to do this with lang or other things, but user has to be double quoted. So now I run this query, and now it is again sampling these 100,000 rows, and with the select distinct we see all the unique languages. So PL, I guess, is Polish. There is like select language. That doesn't look really correct. But maybe there was some front end or some mobile app or so where select language, if the user didn't select the language, it made it into the JSON data. Quite interesting. Good. So there is another, so the format we looked at the JSON data guide is this, what we call the flat format, where you have this array of object, and each object has a path, and the path tells us the hierarchy. There is another format which we called hierarchical. So it's the same, more or less the same select JSON data guide, and now we say format hierarchical, also the pretty printing. And the only difference here is we will get the same information. The only difference is that let's go up to the top again. It takes a while to scroll through this long document. Yep, here we get. So now we see that the topmost structure we encounter is an object, and it has properties. One is called ID, whose type is a number, and now we have the length information. We do have something which is the preferred column name. We will get to this later. Let's go to user, for example. Let's search for user. Yeah, here we get user. So user is an object, and under user we will have an ID and a URL. So now instead of having the path reflect the structure, now the nesting of these objects is giving us the structural information. The other benefit or the other property of this hierarchical format is that it's actually a valid JSON schema document. So there is something called JSON schema. You can look it up online and you can use it to validate JSON documents. So you would have to do this in the mid-tier. We don't have JSON schema support in the database yet, but you can sample your data, or you can, if you have JSON data, you can generate the JSON data guide in the hierarchical format, and you could then take the data guide and have a JSON schema evaluator or validator, for example in Java, to validate new documents against this schema. Okay, so now whenever we calculated the JSON data guide, it took a few seconds, and this is because we sampled or we scanned every row. So in this case, it was 100,000 tweets that needed to be scanned, and this obviously took a while, so it wouldn't scale if you go into the millions or billions of documents. So this is why we also added the JSON data guide as an option to the search index. So the search index is normally used for searches on all the fields in your JSON document. So if you know the fields that you want to index, you can create a B-tree index using functional indexing. But if you want to index the entire document, we have the search index. And now the search index has an option to also have a data guide or to only have a data guide. In this case, we enable the data guide. So now during index creation, it scans the data once, but then if we query it, it will not have to scan the data again. And also if you do updates or if you add rows, it will only scan the newly updated data. So whenever you insert something, you will see that the data guide changes if you insert a new field, but it won't take that long because it's only scanning this one updated new value. So the index got created. And now, because we have an automatically maintained data guide, it will also be accessible, or it's also listed in a view. So we have a new view called User JSON Data Guides. And if we basically list the table name and the column name and the data guide information. So if we select from this view, we will see that there is a data guide on the JCall of Twitter table. So now we can select this using just select the data guide from user JSON data guides where table name is Twitter table. So if I run this, it will not scan the 100,000 rows, but instead the data guide is immediately accessible. So if I now insert a new value, it's a new field, foo bar. Foo does not exist in our data yet. And if I commit this, then this new row should have been scanned, and we identify that a new field name exists called foo. And now if I select the data guide here and I search for foo, I will see that this exists here. So there is foo. It was a string that I provided. The value was actually bar, 3 characters long, but the next power of 2 is 4. So 4, it fits into varchar 4. And with this option, the data guide actually runs in the background on any insert or update and won't take that much time to check if a new field exists. I think in the real world, once you've inserted a few 100,000, 10,000 rows, you've seen all the fields. So what the data guide does is during parsing, it also checks if we see new fields, and it does this in memory structures. So it doesn't really add much overhead to the parsing of the JSON that you're gonna do anyways, because you have the isJSON check constraint on your table. So now the foo row that I inserted, I gave it the ID 1. So let's delete it again and commit. Now if you select the data guide here, you will still see that foo is there. So if I go back and I search for foo, there it is. So what we're not doing is checking when you removed the last occurrence of a field name. That would be much more expensive, because now for every delete we would have to check what fields are being removed and do some sort of ref counting. That is just too expensive. So the data guide only works in a additive fashion. If you see a new field name, it's getting added. If you remove a field name and it happens to be the last one, well, you're out of luck. If you need that precision, then you have to run the aggregate function, the select JSON data guide, which scans all the rows you have. Then you have very accurate information. So what can the data guide be used for? Well, since we know the path to all these field names or the values associated with these field names, and we also know the data guide, we can automatically create a view for you. So in the DBMS JSON package, we have a procedure called create view on path. We give it a view name, we give it the table name, and the JCol, the column name where the JSON data resides, and we say $ is the path expression, meaning like index everything. So now we have our view. Let's just see what the column names and data types in this view are. So we see we have 313 different columns, and these are the column names and their data types. So now I could select, for example, the geo from this view. So let's see how many rows we have in the view. So remember, we had 100,000 rows in the original table, 100,000 tweets. Now we've created the view, and we see that more than 100,000 rows were returned. So 100,000 input rows generate us short of 340 output rows. Well, how is this possible? Well, as you know, JSON can contain arrays of values, and we will unnest these values using this nested path in JSON table. So how is this view working? Well, let's get the metadata of this view using select DBMS metadata, get DDL. So this is the DDL for this view, which we could have created manually if we were very brave. So let's go to the top, probably just a huge, yeah. So this is the view. So create or replace a view 1. These are all the column names. Well, where do they come from? Let's scroll to the actual. Yes, so they come from our Twitter table, and we use the JSON table row source, where JCol is the input. Then we have the list of columns, so JCol ID gets the path ID, or JCol type gets geo.type. And then there is the nested path. Because geo is an array, we unnest this array to give you relational access to the values inside this array. So we iterate over the array of coordinates, and then we have the number value out. This is the latitude, longitude. Well, we don't know that it's latitude, longitude because it's not associated with a name like this. It's just an array of 2 numbers. And similarly, we see, I guess, other nested paths here. Yeah, there's a bunch of nested paths. There is something else with coordinates, which may also be X, Y. There is place IDs. There is entities URLs, media. I don't know what this means. I would have to, again, then look at the data to get some understanding what this could be. Yeah, this is user mentions. Maybe user can mention other tweets, so it could be more than one. So this is why there is an array, and then the ID is, or the tweet is then referred by an ID. So you get the idea that you have a very complex JSON table statement here that is defining the view. It would be very hard to write this manually. Just pages again. But this is why we automate it using this create view on path function. So now since we have the view, we can just select the jcol.lang. This is what you saw before in the schema where it says preferred column name. Let's see if we can. Yeah, there was this preferred column name field, and those would be the column names that we auto-generate. Sometimes they're, well, I hope often enough they're meaningful. Sometimes you get some numbers added because the string is not unique, and then by adding the number you get it unique. But you could change this. So you could say, well, this is status ID or something like this, and then if you generate the view using the data guide, it would pick up the column name that you've chosen. So yeah, going back to the query, so we queried this view 1, jcol.lang. Now we see the languages that were used here. It's a different list because it's probably pointing to a different language in our tweet data. So I think this is the language of the tweet and the other was the preferred language of the user or something like this. Now, what we did in view 1 was to expand every possible field in the data. Remember, the path expression was just $. What we could also do is pick a path that is not the root, for example, $.user. This would expand only the fields under user. So this is view number 2. So if we select from view number 2, we still get 211 rows. So there could be 211 fields for every user. Not every tweet will have all of them. Most likely, any tweet you look at will have a much smaller set of field names, but in total it could be 211. So let's say you're not interested. So I guess you only have 211 because a lot of these fields are missing in some instances, or it could be null values, so they're not bearing always data. So what if you were only interested in those fields that occur often or all of the time? So that's possible if you tell the data guide to also gather statistics. So we're now gathering statistics on this table, and this way we also check how often a field occurs. So there is an additional parameter after the path expression, which is the percentage of how often a field should occur. So if I say, let's say 50%, then a field has to at least occur in every second document. And if I do 100, then I should only get fields which occur every time under this path. So only the fields that really exist in all the documents. So I've created a view with 100%, which is called view 3. And let's see how big view 3 is. Well, it only has 58 rows. So those are most likely the fields that will always occur in your tweets. Okay, so another possibility of the data guide is, since it's being executed on every update or insert, if you have it part of the JSON search index, we can also use it to track changes. So in order, for example, to get notified if new fields occur, let's say I'm a DBA and developers use JSON to store data. Well, because it's JSON, they could add any field name that they please, including social security numbers or credit card numbers. So with the data guide, it's also possible to identify that a field is new, it doesn't exist in the data yet, and you can get notified. So how do we do this? In this example here, we create a table called JSON changelog. It has basically a bunch of columns like table name, column name, and then we want to have information what field got changed in this table and column, so it's the JSON path and so on. I'm just creating this table here. It already existed, I forgot to delete it, so how to drop it. Well, anyway, so this table was already there. I mean, I did a dry run here, and I create a procedure. So this procedure is called log JSON changes, and its signature is that it gets a table name, a column name, a path, a JSON type, and a length. So this is the information that the data guide collects, and any procedure with this signature can be passed as a callback to JSON data guide. What we do inside here is we basically only insert in our table. That's all we do. So it's only one big insert statement where we take the values that came in as input parameters and we insert them into the table together with some timestamps so that we know when it got inserted. So the procedure got there, got created. Now I'm altering the index, the search index, and I tell it to keep the data guide on, and when there is a change, to call this procedure that we just created, log JSON changes. So whenever data guide detects a change, call this procedure, and the procedure will write into the table. So let's select from our JSON log table. Hopefully it's empty. No, it's not empty. That's a leftover from the dry run. So just gonna delete it. Okay, now if I select, it should be empty. There it is. So let's insert a field like created at. So we insert it. Our changelog is unchanged. Nothing gets written into the changelog. And the reason is that created at is a field that's already existing in our data. So if I search for this, there is this field created at, the type was the string, length was up to 32. Now, because our length fit into the 32, there was no change detected. So let's just for fun make it longer, that it doesn't fit in there. This is no longer a date, but since it's JSON, it probably won't fail. So let's see, changelog. Yeah, so we see a change. Created at got changed, and the type is now not fitting into 32. It's longer than 64, so this is why it jumped to 128. So in this example here, the field name didn't change, but the length of the type changed. So data guide detected it and gave us an update. So let's delete again. So we knew we were notified of this change. It's an okay change, so let's say this is okay, data has changed. But let's say now some of my rogue developers stashes in credit card numbers or social security numbers. Then in this case, that's not good. Again, we see the change here. There is a new field, credit card number. This was the time when it was changed. So yeah, this is now a point where I may want to react and see if this is really a good idea to put this number in there. So obviously this is just one example to insert in a table. You can also make a REST call and get notified via email or whatever if you want to write this in PL SQL and or some other logic. But it basically allows you to look at or to derive a schema and to do things if the schema changes. There was a question regarding performance. It adds about 5% to the isJSON check constraint evaluation. So remember, if you run the isJSON check constraint, we have to scan the JSON text, which is not a very cheap operation. So then while you do this, also checking if a field is new is not that much more expensive. So performance is not really hurt by this. We had another question regarding validation. Is it possible to use the data guide or the JSON schema, the hierarchical version of the JSON data guide, to validate it? There's no built-in support for this yet. You could obviously have a Java implementation that you run from PL SQL, or you could run it in a mid-tier. So yes, if you do a little bit of PL SQL work, you could hook this up.